My dear students, other viewers and listeners, I, Professor Manohar Lal, Director School of Computer and Information Sciences, IGNOU, welcome you to this second part of Algorithmic Techniques for Solving Problems. Friends, in this lecture, we'll discuss a number of characteristics which are required for a method to be an algorithm. After that, we'll discuss the significance of tools available for solving a particular problem through solving the same problem through different sets of available tools. So friends, first of all, I'd like to discuss the difference between the three nearly very closely related concepts, namely the program, the algorithm, and a process. You may look at the slide. A process, a program, and algorithm, as I mentioned, are very closely related, but there is some difference. A process is a sequence of activities. Please notice the word activities, actually being executed to solve a particular problem. For example, when you are baking a tasty pudding, then actual stirring, actually igniting the fire, and all those things are very important. It is the actions of which a process is constituted. On the other hand, algorithm and programs are just description of actions. When you say write, W-R-I-T, write this. Now, write this is a command or a statement of actual process of writing. So the difference between a process on one hand and algorithm and programs on the other hand is that a process is actually what happens in the real life. On the other hand, algorithm and programs are some descriptions of that in case of writing a letter you should do this, etc. And whatever is the description when written on a paper constitutes an algorithm or a program. On the other hand, the two terms algorithm and programs are also very closely related. However, an algorithm is a description or statement of a sequence of activities that constitute a process of getting the desired from the given inputs when written, not necessarily in a programming language. That is, if you have written it in a programming language or not, whether the description of a process is in a natural language or otherwise, it is an algorithm. However, if it is to be called a program, in that case it must be written in a programming language so that the computer can understand it and execute it. So once again I differentiate between the three words. I repeat that a process is actually what is being carried out. On the other hand, program and algorithms are just descriptions, the statements which can be written on the paper. Further, an algorithm and a program are differentiated by the fact that a program must be in a programming language so that a computer system can understand it and execute it. Next, friends, I'd like to discuss briefly how this term algorithm, which is, as I mentioned in my previous lectures also, is a fundamental concept. Please don't look at the slides. I mentioned that the term algorithm is a central concept. If we are asked the most important concept of whole of computer science, then it is the concept of algorithm. I'll briefly discuss what are the origins of the words algorithm. In this respect, we will have to differentiate between the word algorithm and the actual what it denotes. Actually, algorithm, as we have mentioned earlier also, is a specialized method used for solving problems. And algorithms have been used to solve problems for at least 2500 years. The earliest known algorithm, one of the earliest known algorithms is that of Euclid's for finding out greatest common denominator for two numbers. So algorithms have existed for more than 2500 years or so. However, the word algorithm as such came quite late, and it has a little bit of history. That is, actually there was a Persian mathematician called Muhammad al-Khwarizmi, He had collected large number of algorithms for solving mathematical problems. He was a good mathematician also, but in addition he had collected large number of algorithms in the form of a book. And later on, the book itself, or the process of solving the problems using a systematic method itself, got called the name of the Persian mathematician was Al-Khwarizmi, and from the name Al-Khwarizmi, later on, instead of calling Al-Khwarizmi's process or method, people started calling, the method word was dropped and it started being called Al-Khwarizmi. And then when it was translated to Latin language, it became Algorithmus. And finally when it translated into European language, particularly in English, as algorithm. So it is brief history. The word algorithm itself came into coin, it became in uses only in 9th or 10th century. However, the process of solving problems through algorithmic methods are quite old. In the beginning itself, friends, I mentioned that not every method of solving a problem may be an algorithm. There are some requirements, some characteristics which must be satisfied for a method to be called an algorithm. This is very important for us to understand that when a method becomes an algorithm, at least there are 5 characteristics, there are 5 essential properties which must be satisfied by a method in order to that it is called an algorithm. So friends, what is the first requirement for a method to be algorithm is that finiteness. What by finiteness we mean is that howsoever long the method may be, you need not look at the slide. Howsoever long the method may be, it should ultimately terminate, and that is very justified requirement for a method to be called algorithm, because if a method when executed continues forever, what is the use of it? Because ultimately the answer or the solution's final step, until unless those are reached, we can't say whether we have reached the final step or not, or final solution or not. So the very first requirement, which is very intuitive also, is that a method must terminate in finite amount of time, and therefore each of its step must be consuming finite amount of time, and the number of steps also must be finite. So the first condition for a method to be algorithm is that it must have finite number of steps, and each step must be executable in finite amount of time. And as I mentioned, it is quite intuitive to require a method to be an algorithm to be finite. Second is definiteness. Definiteness means that when a particular step of your solution or so-called algorithm is executed, then under the given conditions or given inputs, it must return the same output. That is, it should not happen that if you start with the same initial conditions and when you are repeating a method twice or thrice, then sometime the answer comes different, the output comes different, then it is not algorithm. I'll make it further more explicit through an example. Please look at the slide. I am giving an example in which the method is not definite, and hence it is not entitled, the method which we are going to discuss is not entitled to be called an algorithm. The algorithm, the method is something like this. You have got a variable x to which you assign a value 1, and for further action you toss a coin, and if the result of tossing a coin is a head, then you assign the value 3 to the variable x. Otherwise you will be assigning value 4 to x. Now friends, you see that in this particular case, when the initial value of the variable x is 1, the next value cannot be determined in advance because the value is dependent upon the outcome of the tossing of a coin. So in such cases, sometimes the next value which is going to be assigned to x may be 3, at other times the value of x may be 4. And therefore, you need not look at the slide. Therefore, the requirement that if you start with the same initial conditions, every time the result should be the same. However, in this particular case, you are starting with value 1 of the variable x, but depending upon the result of tossing of the coin, sometimes of the value of x becomes 3, at other times it becomes 4. Therefore, the outcome is not definite, and hence it is not an algorithm. It is merely a process of assigning values to the variable x. I hope this is very clear. There is another term which we are going to use after some time, effectiveness. Definiteness and effectiveness are two distinct, different terms, and when we come to the discussion of effectiveness, then we will discuss what is the basic difference between the two terms. Friends, the third is inputs. The algorithm or the method may or may not have any inputs at all. It may be surprising that there may not be any number of inputs required for a method to continue and yield results. For example, every computer system has a largest integer which is already known to the computer system. So if you give a command or if you write a method and which has only one statement, and the statement is print the maximum number, it doesn't require any input at all. Or find out the sum of all the integers, natural numbers, less than equal to the maximum that can be stored in particular computer system. It doesn't require any input. So there may be algorithms in which there may not be any input or the number of inputs is equal to 0. However, there must be an output. Why? Because if there is a method and that method is executed by a computer system, and if the method doesn't suggest an output, then what would happen? The computer will not return anything at all. How we should know that what is the final solution which is made by the computer system? So at least one output is essential for a method to be an algorithm. Finally, friends, as I mentioned earlier, that there is one more condition for a method to be called an algorithm, and that is effectiveness. What do you mean by effectiveness, and how the concept of effectiveness differs from the concept of definiteness? Effectiveness actually means that when you execute the various steps, then each should be executable. What I mean by this is something like that. You look at the next piece. For example, please look at the slide. We want to find out the exact value of E, which is one way of finding out the exact value of E is 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial and so on. Now, if we are required to find out the exact value of E, then we must find all the values 1 by n factorial for all n greater than equal to 1. This means the process should continue forever. And this is not effective in the sense that no computer system or no human being or nobody else or no mechanism can carry out the calculation of 1 by n factorial for n. So such a process is not effective. Effective, for example, another example I give you. For example, you have only the surface transport available to you, and you ask somebody to go to moon. Now in this particular case, when you have only available means are surface transport, going up to the moon is not effective. What I mean to say by effectiveness is, whatever tools are available with us, if whatever you want to do cannot be done with those available tools, then it is not effective. And this includes this also, that if a method suggests carrying out of infinitely many steps, that also cannot be executed by any set of tools, howsoever powerful. So effectiveness actually includes finiteness as a special condition, but there may be other situations in which the effectiveness may be different from finiteness. As I mentioned, when you don't have any space vehicle, spaceship or any shuttle or something like that, you have only surface transport available with you, then if you ask a person to go to the moon, this step is ineffective. So friends, I summarize. For a method to be called an algorithm, we require 5 characteristic conditions. First of all, it must be, whatever method is under consideration to be called an algorithm must be finite, that it must have finite number of instructions and each instruction must be executable in finite amount of time. Number 2 is definiteness, that is each step must yield same output on a given initial input or initial. Number 3, that number of inputs may be 0, however number 4, output must be at least 1, and finally the effectiveness, that is each step must be effective, it can be executable, it can be carried out in finite amount of time by the available tools. So friends, with this characterization of algorithm as special method, now we'll go to explain, which is generally neglected by the students, the importance of available tools. We'll discuss that depending upon the available tools, we have to the algorithm which is to be prescribed for solving a particular problem has to be different. So for this purpose, I have taken a very simple example of multiplication of 2 integers, positive integers, natural numbers. And we'll see, depending upon the capability of the person or the available tools, how the algorithms become quite different. So for this purpose, first of all, friends, look at the slides. For example, we have to multiply 2 numbers. One of the numbers is 426 and the other number is 37. Now if our computer system or the person who has to carry out this multiplication knows the tables, multiplication tables up to 10, then the usual algorithm of multiplication comes into picture. That is, first of all, you take the multiplier's least significant digit, which is 7 here, multiply 7 with the least significant digit of the multiplicand, in this particular case 6, then you have some carry and some digits here, and the usual process is adopted. First you multiply with 7, then you multiply by 3, giving 10 times of the earlier one, and then adding up, and ultimately you get the product of 426 and 37. But next, suppose our available tools are not that good. That is, whether it is a computer system or it is a human being, it doesn't know multiplication tables up to 10. Rather, the system under consideration which is to carry out or execute this algorithm only has two things. That is, the system knows only counting and comparing two numbers in respect of less than or equal to. We are given two integers, natural numbers m and n. We are to find out the product mn. However, in this particular case, we don't know the multiplication tables. Rather, in this particular case, we know only two things. First of all, we know the counting, and secondly, we know how to compare two numbers for less than equal to relation. In this particular case, the earlier method of finding out the product of two numbers will not suffice, because the system or the human being doesn't know multiplication tables up to 10. How will find out the product of two numbers when only these two capabilities are known to the system or the human being? And this explains how totally a different sequence of steps has to be there in order to find out the product of two numbers. Please notice it. So in this particular case, the possible solution is that we have two sides of a page, or rather we have two pages. One will be called the left hand page and the other will be called the right hand page. And on the left hand page we mark the two numbers just by drawing a sort of vertical line. We draw m vertical lines on, and then leaving some space we draw the n vertical lines. And on the right hand side, n vertical lines are drawn for each vertical line in m. That is, friends, what we will be doing, we will be crossing one of the vertical lines, and for each crossed vertical line we will be drawing n vertical lines on the right hand side. The process will be repeated m times, and once all the vertical lines in the first row are cancelled, we stop the process. Therefore the process is a finite one. And then we count all the lines drawn on the right hand page. The number of lines which are drawn on the right hand page will be equal to m dot n. But what I want to emphasize here is not the drawing of lines etc., but the fact that now our tools are very poor, in the sense that we know only to count numbers and to find out whether a particular number is less than equal to another number or not. With these two capabilities, we are still able to find out the product of two numbers, but totally in a different way. Whole of the algorithmic method is changed. Now I will discuss another bag of tools which are available to us, and because of the availability of totally different bag of tools, how will we changing our method of finding out the product of two numbers. Please look at the next example. This is a method which is used when the system, computer system, or the human being who is actually attempting to find out the product of two numbers has an additional quality. And what is that additional quality or additional tool or additional qualification is that the person knows multiplication by 2 and division by 2 of numbers. Actually, we expect these two, that is multiplication by 2 and division by 2 capabilities in a person who has very elementary knowledge of mathematics or even otherwise. It was used earlier by Russian farmers, and this is why the method sometimes is called La Russe. So, but my purpose is to tell you that once the set of tools available to us is different, the steps which we are required to take are also different. In the case of second algorithm, when we didn't have any other additional quality except drawing, counting of numbers and comparing of two numbers, we took the method of drawing lines, vertical lines, and finally counting all the vertical lines drawn on the right hand page. Now our method may be a little bit more sophisticated in the sense that instead of drawing lines, we will be going a bit faster. Please look at the next slide. The step is something like this. In order to solve the problem in smaller amount of time, instead of taking larger numbers, I have taken two numbers 45 and 19 whose product is to be found. And here we must know, or must recall, that the capability of multiplication and division by 2 are embedded in the system. So we have to make use of these two qualities or these two capabilities in solving this particular problem of finding out the product of 45 by 19. So what we do, first of all, we take four variables, namely first, second, remainder and partial result. What is the role of the variable first is it stores the multiplicand. The role of the second is to store the multiplier. And remainder will have the role of whenever we are dividing a number, then if the remainder is either 0 or 1, and in case whatever is the remainder, it is stored over here. And partial result is that the process will be something like this, that the first number will be continuously divided by 2 and side by side the second number will be multiplied by 2, and in case the remainder is 1, then suitable adjustment is made. So that is the basic process which we are going to carry out in order to find out the product of two numbers when the additional capability of division and multiplication by 2 is there in the system or the human being who is carrying out. So initially the partial result is taken as 0. Now what we do? First of all, we check whether the number under first is 0 or not. Once the number under first becomes 0, we stop. And whatever is under partial result is taken as the final result. So what we do here, we divide, because the given number is 45, so and 45 is not equal to 0. This means the rest of the steps will be executed once. What we do, first we divide 45 by 2, and after dividing it, we get 22 as a quotient, as we know, and one remainder is left. I hope it is clear to us. But at the same time, because we have divided by 2, we should multiply the second number by 2. So the second number now on multiplication of 19 becomes 38. Again we will see whether the first number is a 0 or not, and because the first number is 22 at this particular stage, therefore which is not equal to 0, therefore again we will be dividing by 2 and multiplying by 2. So next step is something like this: when 22 is divided by 2, it gives us 11. On the other hand, when 38 is multiplied by 2, it gives 76. Friends, you notice that up to this stage we haven't used any tool except the fact that we are either dividing by 2 or multiplying by 2, and at some stage we are adding also. That will be, so there are three capabilities in our system which is attempting this particular algorithm: division by 2, multiplication by 2, and addition of any two numbers. Now again 11 is not equal to 0, therefore we will repeat our process. And at this stage, when 11 is divided by 2, we get 5 as a quotient and 1 as remainder. So what we will be doing, because we are dividing by 2 the first number, we should multiply the second number by 2, which gives us 70, 6 multiplied by 2 is 152. But because there is a one remainder here, so in this particular case the previous number will be also added. So we will be getting in this particular case 152 plus 95 is equal to 247. Again the whole process is repeated. Again 5 is divided by 2 and 152 is multiplied by 2, and whenever the remainder is there, the previous is added, and in this way we will be getting the final result as 855. At this stage, we see that the quotient is of the first number becomes 0, and this is an indication of terminating the process. So the whole exercise of discussing 3 different algorithms for multiplying 2 numbers is aimed at to show that once the available tools are different, our sequence of steps and the steps themselves may have to be totally different from the other ones. And generally this fact is not taken into consideration by our students while writing an algorithm. We must first of all collect all the available tools with us, and then and only then we should think of writing an algorithm, because the algorithm depends upon the available tools. Friends, because the computer system is already a built one in which the hardware and software are already given to us. So what are the basic capabilities which are embedded in a computer system in order to solve problems? We must know, because just now I mentioned that when we attempt a solution with the help of a computer system, we must know its capabilities. So next we discuss what are the basic capabilities for doing processing that are built up or built in a computer system. You will find out these capabilities are generally very elementary ones. And you can see with these elementary capabilities, we are able to solve very, very complex problems. One of the basic reasons behind getting solutions of very complex problems with the help of these elementary operations is the speed of a computer system. Because though the computer is executing very, very elementary steps, but the number of steps which it can execute may run into millions per second. And therefore, despite the fact that the actions taken by the computer systems are very elementary, because of the number of operations running into millions per second, the answers come very fast. But before that, let us discuss what are the basic inbuilt capabilities in a computer system in general. So look at the slide. The 3 basic instructions or 3 basic actions which a computer system can take are: number 1, assignment of a variable. Friends, if you are given a variable and you are to assign some value to this, whether the value is through an expression or otherwise, then a computer system can do that. It is inbuilt mechanism by which a variable can be assigned the value which is either already computed or is required to be computed. So assignment is one of the basic capabilities or basic instructions in terms of which the rest of the instructions are written. The next is read. That is, you are given a variable and you want to give a value to this variable, not through computation but from the environment. That is the difference between an assignment and read statements. In the case of read, the value is given by the user or by the environment. So what is the format generally of read instruction in a computer system is something which is given on the slide, please. Read I, comma, j, comma, etc. What that means, that the computer system is given an instruction to read from the environment the value of the variable I, the value of the variable j, and while executing this particular instruction, what will happen? That first of all, when this instruction is encountered by the computer system, first of all it will stop and it will ask for the a value to be given, which will be assigned to the variable I. Once you have given a value, the computer system assigns this value to the first variable mentioned under read. Once that is read, then if there is another variable, in this particular case j, then again it will stop and ask you to assign a value to that variable j. So till all the variables are not exhausted, the computer, after taking a value, will stop for the next value to be assigned. So this is the second capability in a computer system, or second basic instruction, which is there built in every computer system. And third is write. Again, the actions are almost similar. However, in this particular case, the computer doesn't stop for asking values from the environment. Rather, if write I, j, k, etc. is written over there, the values of I, j, k must have been computed earlier by the computer system, and those values are printed out or given on the screen. So friends, these are the three basic type of instructions. Once I repeat it: the assignment instructions, the read instructions, and the write instructions. Apart from that, there are many other processing capabilities like addition of numbers, multiplication of numbers, editing of paragraphs, deleting a word, deleting a paragraph, etc., etc. Those are different processing capabilities in addition to these three basic type of instructions. Now you have a set of instructions or a repertoire of capabilities available to us, but that doesn't solve a problem. For example, if you have tables of multiplications up to 10, this by itself does not solve a problem of finding out the product of two large numbers. Rather, the process which you are describing must have some ordering. First you do this, then you do this, then you do this, then you repeat a whole of this sequence of instructions, etc. So what are those control mechanisms which are used for instructions? So there are three fundamental control mechanisms used for writing instructions. The first is direct sequencing, the second is selection, and the third is repetition. What direct sequencing means, that when you are trying to find out this solution, then write the first instruction, followed by the second instruction, followed by the third instruction, and go on this process of writing in a sequence. This is called direct sequencing. For example, if the solution consists of instructions A, B, C, D, and those A, B, C, D instructions are to be executed in this very order, then you can write A semicolon, B semicolon, C, D. What computer system will do? First it will read the instruction A and execute it. Once the instruction A is already executed, then it will start executing B, but not before that. Similarly, when the instruction B is already executed, then it will start the execution of the instruction C, and so on. This is called direct sequencing. Then the next is selection. But friends, we know many of the problems require this type of situations. For example, if you are computing income tax and there is tax exemption for, say, amount of rupees 1 lakh per year, and then the tax rates differ. For example, tax rate on the next 2 lakh rupees is, say, 5%, and tax rate for the further 2 lakhs may be, say, 10%. So here you see you will not execute the same sequence of steps. You will have to select the rate of text depending upon the amount of income. So in this particular case, direct sequencing will not be enough. At some stage you will have to say, if the income is more than this, then the tax rate is this, otherwise it is this. So there is a sort of selection. So in this type of situations, what we do, if a condition Q, that is if the income is more than 10 lakh rupees, then you will do this, and if it is not, then you will do this. That is, the tax rate will be something, say 5% if the income is less than 10 lakh, and it is 10% if the income is more than 10 lakh. So here a selection instruction which is generally written in the form, if Q is a condition which may be either true or false, then depending upon if the condition is true, then you will be taking the action A, and if the condition is false, then you will be taking the action B. Friends, the third type of instructions, well, this can be also made like this one, depending upon if the variable Q is not a binary valued, then in that case, depending upon the different values you can discuss. For example, if the value of A and B are the values of Q, then you will be taking action A. If the values are A and C, then you will be taking the action B, and so on and so forth. Similar repetition. Friends, sometimes you are calculating, say, income tax for not one individual but lakhs of individuals. Generally programs are not written to solve problems for one particular individual in such situations. What you will be doing? The same sequence of instructions may be repeated for thousands of people, thousands of times. So there must be some mechanism in your program which repeats the same sequence of instructions, and for that the repetition control mechanism is used. And for this, the syntax may be something like, while Q do begin S end. What does this mean? This means the condition Q is true, then you go on doing the sequence of instruction S, otherwise you stop. So I'll take an example just to explain this. For example, we are to find out the sum of the first n natural numbers. So how the repetitive control mechanism works in this particular case? What we do? We use two variables. In the variable x, we will store the consecutive integers, and in the second we will find out the sum. And while x is less than n, we will be increasing x by 1 so that consecutive integers are stored in x, and at every time we will be adding that number to sum. So this is, you can see the two instructions, x is assigned x plus 1 and sum is assigned sum plus x. These two instructions are repeatedly executed till the value of x becomes n minus 1. So this explains the repetitive control mechanism. Friends, in the process we have explained two important things. What are the 5 essential characteristics for a method to become an algorithm? And number 2, the availability of tools determines the algorithm or the method to be executed in order to solve problem. And then we finally told you the various control mechanisms and the basic instruction, 3 basic instructions: read, write and assignment, and 3 basic control mechanisms which are direct sequencing, repetition and selection. So I hope you must have understood the fundamental aspects of an algorithm. Thank you. Rest we will complete.